Okay, so before starting, I just want to remember you the schedule for this week and next week. You know that these rooms are not available across the weekend from Friday to Tuesday, because there's the open days that are taking place in these rooms here. Okay, so instead of finding another slot and creating problems, we decided to take the labs for this week and the lectures for next week to be online. Okay, so we will continue with the same exact schedule and time. So instead of coming here and we will publish here the Zoom link on which you can connect for having support during the labs. Our suggestion would be to create breakout rooms so that people in the group can work together online, or if you want to work together in some location, you can just organize yourself. Just remember that all this block will be used by the open days, so even the study rooms will not be available during those days. So either online or you can find a place at a friend's or whatever for Friday. And next Tuesday also the open day will still continue, and we have the classical lecture online again on Zoom. Okay, so I'm sorry for this, but I hope it doesn't create too many problems. The lab for this week is linked to the reading of basics of HTML and CSS that will be taken as an exercise in the next second hour. So in the second hour, Francesca will come and work with you with some hand design of HTML pages, and especially how to use Bootstrap for CSS instead of, we are not going to become masters of CSS, because that would be a skill in itself, and it's very deep indeed. So we use some library like Bootstrap for designing the web pages, and in the second hour we will do that, and in the lab you will do the same on your project, okay, for this lab of this week. While at the same time, today and next week in the lectures, we are going to start React and see how to change actually the design methods using the React library. And so next week, actually, the lab of the 4th of April will be translating into React what you will do this week with just plain HTML. Okay, translating something from a static implementation to a dynamic implementation, the first step at least. Okay, so we are starting to work on the front end, and later on we'll try to join the front end with the back end that we worked on until last week. Okay, so that's the plan. Talking about React, so it's a different way of thinking about the development of application in the front end. We are going to work on with version 19 today, that was just out this year. It's quite popular. It's one of the 2 or 3 most popular frameworks. There are several frameworks. They have more or less some ideas in common. And these ideas are to try to simplify, from the programming point of view, the management of the application state and all the asynchronous events. Okay? So when we had some asynchronous event in the database, they were very simple. They were just reactions to an operation that we started. But in a graphical user interface where you have hundreds of elements in a page that can create different events, different actions, it will be very difficult, by hand to coordinate all these activities and to understand when you change something in a part of the page, what should be updated in other parts of the page. So the approach taken by this framework is to try to manage this part for you. So we won't have to deal directly with events. We don't have to deal directly with the modification of some part of the page. But it will be managed by the framework if we follow its rules. So we are less free in programming. We need to follow some extra rules that are rules dictated by the framework, in exchange, it will solve many problems for us. And okay, React is very well documented. By the way, they rewrote the full documentation a couple of years ago, so now it's very much more readable, and it has extensive tutorials and say API references with a lot of examples and also suggestions how to use that. So actually there are books out there, but the website is actually very informative. For helping us debug React applications, we can use they developed an extension to the browsers called React Developer Tools. You can install it on Chrome or Firefox as you want, or on Edge, different browsers, and it will help, will extend the console, the browser console, with the capacity of browsing and React components and seeing the state of the component. But we will come to that let's say later on. So, but before delving into React, let's just take a moment to understand how JavaScript lives into the browser, inside the browser. Okay, so it's no surprise that the browser integrates a JavaScript interpreter, okay, that implements the standard library, and that's okay also. Okay, so whatever we learn from Node.js still works inside the browser. But the browser is a controlled environment, so the application should have controlled access to its environment. What I mean is that if I'm running something on a server, I am the owner of the server, I am the author of the code, and I am the one running it. So it's all under my control and under my responsibility. If I visit a web page that downloads a JavaScript program, okay, the author of the JavaScript program is the person who put up the website, but the execution environment of that JavaScript program is my computer. Okay, so actually JavaScript will be the perfect virus, because just by visiting a website, I am running on my computer some code that somebody else has wrote. So that's why the JavaScript code running inside the browsers has a lot of limitations of what it can do. Especially, it should only be able to interact with the content of the web page in which it was loaded. It cannot just open files or open connection or something like that, network connection or database connection or whatever. So there are limitations so that the JavaScript code can run inside the environment of the page. So we have the standard library with the standard JavaScript function for, say, data structure manipulation. Plus, we have an extension of these libraries that gives our program limited and control access to the browser in which it's running and to the web page in which it's running. Okay, the browser and the web page are two different things. Okay, so if, for example, I had this page open, a JavaScript code that could run inside this page could have access to some functionality of the browser. For example, navigate to a new link, go back and forth with the history, refresh the page, not much more, basically, control the navigation of the page, jump to another page and so on. We can do that. Or it can have control over the content of the page. So it can, create a new line, delete it, or, for example, even this behavior here is managed by a very little code, part of JavaScript code that will handle the click event on this button, for example. Okay, with a small animation. So something that is modifying the content of the page. So the JavaScript code can have access to basically two objects. One is an object called window that represents the window, the browser window, in which the application is running. Okay, so it's the interface with the browser. It's called the BOM, Browser Object Model. Actually, the browser gives you some objects, basically location, for example, represents the URL of the current page that can be queried, can be changed, can be modified, and will trigger navigation. There's the history object that you can query to check the history of the current page, and something more. Okay, so these are objects that these don't exist in Node.js, of course. They only exist in a browser, and they are the interface between the browser itself and the frame that contains your web page and the JavaScript code. BOM, browser object model. And we have another object that constitutes the so-called DOM, document object model, which is far more important, that gives access to the document itself, so the web page itself. So all the aspects of a web page are represented as an object model according to this DOM standard. So what is a document object model? It's a set of objects, of course, and these objects represent all the elements in our web page. And these elements could be tags, like the div, the p, the image. Each tag is an object of type element, HTML element to be precise, and they can be nested, so they form a tree, and each of them can have some properties, some attributes. So actually this is a tree composed of nodes that can be element nodes, tags, or text nodes, the final text that you write, plus attributes, which are all the properties you put inside tags. All of these organized in a tree, starting from a starting node called HTML element. Okay, and there's a bidirectional link between this set of objects. You can create those, you can manipulate those, and the browser will keep in sync at any time the content of the page and the content of the DOM. So if in JavaScript I want to modify, delete a row from a table, for example, this is a table, so the table tag contains inside some table row that contains some table data and so on. If I want to, for example, delete this node here, is a table row, for example, from the object model, that's a remove method on node list. If I remove it, the web page immediately, or that row immediately disappears from the web page. On the other hand, if there is a form online, and the user is typing something into a form or just clicking some checkbox, the properties of that checkbox or that text field in the document of the model will be updated in real time according to what the user is typing. So actually, we have two views of the same thing. One is the user view, what the user sees on the web page, and the other is the programmer view, which is made of this set of objects, their properties, their methods for creating, for registering events, for doing everything. Okay? So inside the web page, the JavaScript code has full control over the content of the page, not on adjacent page or other tabs in the same browser, only on inside the tabs in which you're living. But you have full control, and this control comes through this standardized DOM model. The DOM is the way we should work if we didn't have a framework. If we want to work with plain JavaScript, we have to learn how to manage this tree, how to create nodes, how to delete them, how to move them, how to register event handlers, and so on all of this. Okay, it's not complex, but it's the, let's say, the basic low-level access, the lowest level access that we have into the page. And basically, all the interaction, again, is handled in an asynchronous way. So you register an event listener. For example, here on this button, when I click here, I want to execute some JavaScript code that will modify maybe the visibility of a part of a component on the page. So, for example. And so we register a lot of event handlers on the parts of the pages that need to be interactive in some way. That's what we would do without a framework. You see that there's a very long list of events that can be captured and managed directly. The issue is that it becomes very complicated because you have many event handlers throughout your code that react to different user actions, for example, and in some way we need to coordinate all of this, okay? Because maybe there are two different ways of executing some actions, or if I click on a button that will increase some value, if that value is reported in different parts of the page, you should remember to update all of them, or something like that, okay? So it's very difficult to keep track of everything. So what React will do, it will give us an easier way, let's say, of managing all these events. We will be able, of course, to schedule event handlers because we want to take care of what happens in the page in an interactive way, but the execution of the handlers is more controlled, as I said. Okay, it will separate more the phase of handling the events from the phase of updating the page, while in plain JavaScript you have everything together. Okay, so we are not going to learn DOM level programming, okay? Just to understand that actually it's the way the page is represented, and we are manipulating through a virtual DOM that is provided by React. How is React working? How does it force us to think? Okay, in React we never see or touch directly the DOM. You never decide which operation comes before another, and you just declare for every part of the page how should it render itself. Rendering is the main word in React. Rendering a part of the page means creating the HTML for that portion of the page, starting from the information that you have, starting from the data that you have. So we will break down the page in many components that basically are functions in JavaScript, nothing more. And each component has one responsibility of integrating the code to render itself. Rendering itself means creating a portion of HTML corresponding to its visualization on the page. Maybe the component will not render the full HTML itself because a component will delegate to other components that are nested inside it their own rendering. Okay, so a function can call a function. We can say that the rendering of a component will also render some other components inside. So actually we have a function that says, okay, if I don't know, the score of an answer is 3, then I could have a component with the stars that, starting from this 3, will render maybe 3 full stars and 2 empty ones. Very stupid logic. Starting from some information, 3 is the score of this answer. I will render a fragment of HTML with 3 yellow stars and 2 gray stars. That's it. I have a function for that. And then I have a mechanism for calling that function, or say, using that component in different parts of the page, of course, by providing the argument. Maybe it's 3, maybe it's 2.5, maybe it's 5, and so on. Maybe not defined. And so the component will, of course, behave differently according to its input parameters. It's a function, after all, so it receives some inputs. The idea is that we never call these functions explicitly. We just declare how these components behave, the function body, and how they are nested inside each other. And then it's the library that calls the functions when it needs to render a part of the page. The library knows when some data change, and it has an algorithm to check which part of the page needs to be regenerated, needs to be updated. And regenerating a component, maybe we have 3 stars, it needs to be 4. Okay? But the component itself doesn't care. First, it has been called with a parameter of 3. Okay, I will render 3 stars. And later on, I will call the same component with an argument of 4. It will render 4 stars. And the new rendering will switch in place of the previous one. React component never thinks about what is happening. Oh, I need to increase the number of stars. No, I receive a number, 3, I render that component. I receive another number, 4. So they are fully pure functional components. They only depend on their inputs. They don't care why or when they've been called. They just have one duty. Starting from the arguments, from the number, from the parameters, create, render a part of the page. Everything else, well, not everything, most of the rest of all the coordination on in which order do I call the components, in which order do I render them, when do I have to refresh them, and so on, it's all the framework's duty. So basically, in our mind, React is a functional library that requires us to define components that are functions that create a fragment of the user interface, starting from some arguments that they are called props or properties. They are the arguments of the function, and maybe some internal state. Some internal state because maybe something is being inputted by the user, or we need to count the number of times a given action has been done, so we need to remember something internally. Okay? The surprise is that most of the components don't need to manage internal states, so they only rely on properties, and the state of the application is mostly concentrated on some important component that is not distributed over all of them. So we will first start with a component that don't have a state, and then later on learn how to introduce the state into them. Functional behavior means also immutable data. So all the properties that you are receiving, so the argument of the function, are immutable, and all the results of the function should be always new objects. But we already have this in mind when we learned about functional programming. Okay, creating new objects and never modify current objects. Actually, it would be impossible to modify the data that you receive, because if the function is called again, it will be called from scratch with the new values of the parameters. But we have some constraints over the place and the way in which we can store information, because we must ensure that these functions are actually pure. So if I call the same function twice with the same props, if the state didn't change, they should recreate the same identical HTML code, the same identical fragment of the page. Actually, what happens in debug mode, in development mode, is that the React library is calling every component twice, just to check if two different renderings will actually really create the same value. Otherwise, it will give you an error. You are creating a component which is not functional. So we must be careful, okay, how we handle data. And the rendering of the component is automatic. The React library is rendering your component. This is jargon, mean calling your function. Rendering a component means just calling the function that describes the component itself. Every time it's a function only depends on the state of the property, so it only needs to be called if the state changes or if the property changes. And it calls automatically once one of the two or both are changed in an order that is decided by the library itself. Then a component can, if the state and the props are identical, the output should be identical. If the state or the props are different, then the component can render whatever it wants, even slightly different or totally different. We don't care. We have total freedom. Okay? We could be worried about performance of this approach, because actually it means that instead of just, I make the example of these stars, instead of taking the fourth star, I get 3 yellow and 2 gray, okay? I want to switch to 4, and so actually the only operation I have to do is to modify the fourth star, the star number 4, making it yellow instead of gray. And with this component-based approach, actually I'm creating a new set of 5 stars, 4 yellow and 1 gray, instead of just modifying 1. So I'm throwing away the 5 stars that I had, where 4 of them, the first 3 and the last one, were perfectly okay, and instead of modifying 1 of them, I'm recreating all of this. So one could imagine it should be very slow, because we are recreating part of the page where maybe only a small number or small icon has changed. We should not worry about this, because we are not really modifying the web page with our functions. So what React is very good at doing is say, okay, let me show your new HTML, the new stars, and let me compare them with the old ones. So this is all done in memory, in data structure, without modifying the web page. And it will do a difference check, and we only modify actually inside the browser only the actual differences. So we, as programmers, don't need to be careful about only modifying what has been changed. We just recreate everything, and we let the algorithm do the comparison about what has been changed or not. And we'll only actually implement the changes for that single star. We need to provide some help. Actually, what React is doing is comparing 2 graphs. The graph of the page before rendering and the graph of the page after rendering. And it will modify only the DOM for those nodes in the graph that has been changed in the meantime. This is all automatic. We need to give a little help. We'll see how, to the algorithm to be able to compare these 2 graphs, because in general, you know that isomorphism of graphs is an NP-hard problem, so we don't want it to spend. But with some hints, the graph will be very similar, and we will help the algorithm identify the changes. So actually what we are seeing here in React is that we are not working with a real DOM. We are working with a sort of virtual DOM that is provided by the library. We make modifications, we recreate this virtual DOM of the page, and then the matching algorithm will just propagate the modification to the real DOM when it's needed. That's why actually it's not so slow. It's not very demanding to update the data structure. Is much more demanding to update the whole web page, and it's only done minimally. Okay. So how do we work in React? Here's some code, but we never got this low. Like, actually, what we have here is some web page that contains a main node in which we want to, the jargon term is, mount our application. So imagine an HTML page with maybe a div element which is empty. Okay, that would be the element in which we want to mount, in which we want to insert our application. So here there's some code here. We are not going to write it by hand. I'll show you how to generate it automatically in a second. But we find a node, an initial node, a container node. Here is the DOM manipulation. I check an element with this ID, and I create the root node of my React application. And then we have some render function and says, okay, inside this node, insert a div element with some property, and inside this div element, inside the h1 with the text, and after this a paragraph with another text. This is what React is doing. It says that inside that root element, which actually is a normal HTML element, insert a set of nodes. This will be difficult to read because we are creating nodes with some constructor function. Okay, React.h1 is a constructor function that creates a a node in the virtual DOM representing it h1 title. React also invented a simplified syntax for representing all of this. And the simplified syntax is called JSX, that looks like HTML inside the JavaScript code. So when we write code in React, we are mixing normal JavaScript code with JSX code, which looks like HTML, which a couple of more, let's say, syntax rules, that is automatically translated into the creation of the nodes. So this is much more readable because we see what fragment of HTML will be generated when we render this node, this component. Okay? So let me just skip to the practical, then we can go back to the concepts. Since we are not writing directly in JavaScript, and we want to use this JSX syntax, which is not understood by the browser itself, our code needs to be translated. Means we write some code, and then before running it, there should be a translation from JSX into normal JavaScript, so that it can be executed. So we need to set up quite a complex build system for doing all this translation while we work. We cannot just start writing code into the browser in React. We must set up a project with some dependencies, and these dependencies will contain also some, say, compilation step to compile JSX into JavaScript. Okay, we can do that, and there are several ways or libraries that will help us to scaffold the project. Okay, the simplest ones so the React is just a library, but to work, the code needs to be inserted in a set of dependencies, in a set of compilation rules, and so on. So there are tools that help us to create a project with all the settings, and we are going to use this Vite. I don't know if it's Vite or Vite, if you pronounce it the English way or the French way, because they want to think about fast, so I would probably think the French way. But to create a new React application. So let's follow these steps and see what happens. So I opened a new folder. Okay, I opened a project here with week 5. Okay, I'm inside here this week 5 folder. So take any empty folder, and we want to create a new project. So npm create Vite or Vite latest, and then the name of the application, the name of your program. Okay, so maybe we call it demo. The first time you run this, npm will download the Vite application, then run it. Probably I already done it in this computer, so we'll not download it. We'll just run. Okay, no, it says you need to install these packages. Okay, yes, this is only the first time you need to download and install Vite. Okay, once it's done, it will ask you, okay, do you want to create a new project? Which library are you going to use? React. Enter. What language do you want to develop in TypeScript or JavaScript? Or okay, JavaScript. And it's done. So a couple of questions, React, JavaScript, and what we have here in this project is now a folder called demo, which is the name of our application, with some files that have been created. These files, by the way, contain an index.html that normally we never touch. The index page, we see it contains basically an empty div, an empty node, that will be the node in which our application will run, and will load a script. So the index.html, which is the starting point of the application, is just an empty page with an empty node, and it calls JavaScript code. And where is this JavaScript code? Inside the source folder. So all our code will be implemented inside this source directory. And in particular, we have this main.jsx that creates the root of the application. There's only one root, so we only need this once. And this application will call a component called app. So our work starts here. We have an empty page that contains a node that mounts a root element that calls the app component. All of this is standard. We don't need to touch it. Our work starts from app. And app, you see, is written in JSX, is a component that we are calling, and we are importing it from the file app.jsx. And app.jsx, finally, is our main program, is our application. And you see that this file is is the hello world being created by Vite. It contains one function called app. So this is the way in which in React we create a new component. Function, name of the component. And we return the rendering of this component. What we want to return is a div that contains some links, contains some images, and so on. So you see, it's a very simple function, app, that is called in a proper place, and its unique goal is to return some piece of HTML, some fragment of a page. And this is a complete application. Okay, there are all the CSS, all the details, but the idea is that we start from app and we modify it to suit our needs. How to run it? It says, I need to go inside the demo directory, so cd demo. And inside this directory, npm install, because right now we just created this bunch of files, okay? But we cannot run it because we need to download all the libraries. We didn't download the React library yet. So npm install, and this all needs to be done once, of course. It created for us a package.json with set of dependencies. You see there are some dependencies for running, actually React. We can add our own if you want, but for the moment. And some development dependencies. All of the stuff that we need actually to compile and translate and run and debug. Okay, so let's install all of that. It will take some time, and it will create a node modules with a long list of stuff, okay? Just remember not to commit the node modules anywhere, because you can always recreate it from the package.json, okay? Always have a git ignore over node modules. Okay, right now we have the project, we have the libraries, and we can run it. npm run dev. So run this project. I am in the current folder, on the correct folder, sorry. I run in development mode. And okay, so what is happening here is that Vite will start a small web server, like Express, but we don't need to install and do it. It's already embedded inside Express. That is running in port, in this case the default is 5173. And if we click on that, we see that this application, localhost 5173, that contains this simple page. And it's telling me that if I edit app.js and save it, it will update this page basically in real time. Okay, so for example, if I want to get rid of these two logos because I don't like them, we check these logos are actually this part of the page. Okay, they are just two links inside the div with some images. Okay, let's remove them. If I save and go back to the browser, as soon as I save, or in development mode, where we have this automatic, let's say, updating of the application. As soon as we save something in development mode, the application is updated. So we are I only have one screen, but if you have more screens or more screen area, you can work basically side by side. Okay. So this is the code that we have. Actually, this page is a bit more complex because it contains also a counter that can be incremented when you click on it. Okay, so this is a very basic form of state. This page will render itself with this Vite plus React and so on, but also depends on some parameter, some value that can be updated by the function itself. So you see that the minimum is creating a state variable. We'll come to that later, next week. And creating an event handler to manage the update of the state variable itself. But this should be done carefully because we still need to ensure that this function is pure. Okay, it only depends on the state and on the props. Okay, so this is the basic idea, the basic environment in which we are working. All of this index.html loading main which mounts up is something that we saw the first time, but from now on we remember that our code is inside app. Then we can start to develop inside this component or also loading other components. For example, okay, let's do something very simple. Let's remove everything. Okay, so we can start. I remove the count. So let's start from an empty project. Okay, so our browser will be okay. What's the? I have some syntax error here. Okay, this is an empty application, very empty. We want to see how it works. For example, the example is having some welcome text, maybe, that can be in different languages. Okay, so we could just write. If the language is Italian, write benvenuti. If it's English, write welcome, and so on. But maybe we need this functionality also elsewhere in the project. So I can imagine having one component that, for example, let's create a div. And inside this div, I have one title, a demo application. And below that, I may have a welcome component. So I imagine some normal HTML plus a custom component that I want to develop. Because maybe this component needs to, we need it elsewhere, or just we need it put aside, we don't know to. So this, of course, will not, if I'm saving it, it will not run. Okay, we stopped. So sometimes when we do something bad, we need to restart it. Okay. Save. Okay. So without the component, it works. It writes a big title, demo application. It's in the center of the page because of the CSS that were defined for this application. So if you don't like it, you just remove CSS, but we'll learn next week how to use Bootstrap for the layout. And we want to add, a second component, which is this welcome component itself. That should give an error here, but okay, some errors are shown here in the console, but most of them are, are in the console of the browser, because the code is running in the browser. So it's a good practice to also always have the browser console, the development console open in the right. Let me see if I can make it a bit bigger. Yeah, and it's telling me welcome is not defined, of course. I'm trying to use a component which is not defined. So for how can I define a new component? It's very easy. Just define a function. Welcome. Function. Welcome. And as I said, a React component is just a function that returns a fragment of the page. Return, in this case maybe it's just a paragraph, hello. So if I say this, I should be able to see this hello here. Okay, so actually it's like inserting this part of code in place of the component, like a function call. We are reusing a component. Now I put it in the same file. I can also put it in a separate file. So maybe I can have a folder like components, and inside components I may have a file which is called welcome. Sorry, welcome.jsx, and inside this we can have this function welcome in a separate file. So I can have separate files in which I define components and other files from which I call them. Of course, for letting the component to be used, I need to export it. Like you see, also the app.js was exported. So we have the syntax for exporting. For example, if we only have one component, I can export the default value. Otherwise, I can export a list of an object containing a list of different functions. But in this case, we only have one. And from app, we can import welcome from components welcome. So this should work in the same way. So these are all errors. And just to check if it's actually working, you see we have the app and we have the welcome.js in a separate folder. If I modify this component, the application is updated immediately. Okay, so this is the basic mechanism. One app that creates basically the mainframe of the application that uses different components to compose different parts of the page. And I can organize the components in different files with the export and import mechanism as I like. Okay, every component, the welcome component, this is the nice part, doesn't need to know where it's being used. It only has one job of printing a message in this case. Or maybe we want this component to be more clever and to print a message in different languages. So we can imagine providing this component with some properties from arguments to the function that describe the language in which I want to describe, to write the message. And this can be done by by giving a props parameter to the function. And so in this case, props is an object that may have different properties. We can imagine having properties called language. So if props.language may be defined or undefined. Remember, it's a property of an object. We never know in JavaScript whether the property is there. So we need to decide, maybe can be Italian, can be English, or can be undefined. We need to decide what to do in the three cases. Props will be always defined, so we don't have to do checks for props itself being existing, but maybe it doesn't have the property that we need. So if the property language is defined and props.language is, for example, Italian, sorry, parentheses, we are in JavaScript, then I can return, or I say the message is buongiorno. And otherwise is okay, so let me do one step at a time, sorry, because I didn't tell you how to use variables yet. Return a paragraph with buongiorno. One of the syntax rules of JSX is that all tags must always be closed, okay? There are like parentheses in a function call. So an opening tag must always have a closing tag. In HTML it's not needed, but in JSX it is. Like I did here, if I have a tag without the closing element, I just need to close, use the auto-closing slash here, okay? So the syntax is a bit more strict. Else return this, hello. So what am I doing is that if we have the language property defined and it's Italian, then I write buongiorno. In all the other cases, where it's not defined, or maybe it's English, we write the default message. And so in this case, of course, it writes hello, because we didn't specify this property. So this is the behavior of the component. Depends on the argument that it receives. How can we pass an argument to a component? We can pass the argument by specifying some attribute in the component called. So language equal to Italian. The way of passing an argument to a component is to write some attributes in the JSX definition. And all the properties that we're saying, maybe you can say, formal equal to no. Maybe we have a formal welcome or informal one, I don't know. We can pass as many properties we want, and they will all go into the props object. So in this case, if I save this, I should see the buongiorno here. Just to understand, I can console.log props. See what happens. And you see that I save this and rerun the application. And by rerunning the application, it also updated the welcome component. And here I see what has been passed. So the props object coming from welcome.js is now an object that contains a property language, IT, and a formal no. So that's an object with these two properties. These two properties have been set in the color like this, with attributes, and can be accessed from inside the component through the first argument, first and only argument of the object. So we can also have two different, in the app, two different welcomes. One is Italian and the other is English. I don't know. And if I save, I will have both of them rendered, one below the other. And you see that the component received, the first time received the object IT, and the second time received the object with the properties with English. Don't be surprised that this has been printed twice, because as I mentioned, every component is run twice by React, just to check that you are not playing tricks with the functional aspect. So only the second one is just a verification run, okay? But of course, if you have a log statement, it will show. It's normal. In production mode, this will not happen. But in development mode, it's a good way. You would see an error here if the two renderings differ in some way. So we have a component that can be customized by some properties, and we can use this component many times by giving it. In this case, we have a second property that has not been used, but it's normal, like calling a function with an extra parameter doesn't do any harm. That parameter is ignored in some way. Okay. Okay, so this is the idea. Imagine your page. Let me go back a few slides. We should start imagining our page that will contain our application and identify components, or to break it down into components that, for example, we have blog post or blog post with image preview, so we have a container for all the posts. It could be a component, a blog container or blog list container, maybe, that nests inside three components of type blog. Maybe it's the same component that has an argument to say whether it should be expanded or not. Or and internally, maybe, of course, broken down into many other subcomponents and so on. And then we have another part of the page that is completely different, and we define components for that. So we don't need to think the page as a whole. We need to think the page as a set of areas, of components, for which each of them just needs to identify which are its arguments, its properties that are needed to be rendered. If I need to render a post, I need, of course, to give it the title, or the link, or the image, or the text. This should be given as an input, so that the function, the component, can use these inputs to format in the proper way, the way we want to look at the post. So like with any function, also these components need to have a clear interface, which are their variables, and the input interface, because the output interface is always the same, a set of components. Okay, we will consider that there are basically two types of components that we create normally. There are some, these are called presentational components, or I would say just leaf components. They're the components that actually display something. No? For example, this blog post with image preview or blog post will display actually the content of the post. And so they will take some data and create some HTML itself. Other components, like the ones that are, for example, this boundary here, managing the list or managing the full page and so on, may not generate visual elements in the page. Maybe there are more containers for other components. So they keep together the layout, but mainly also keep together the information that about what we need to display. If we take this element here, imagine these posts come from a server, no? An API server that will give us some information about the post that need to be displayed. So at some point, we need to have some part of the application that contacts the server and gets information about the first and the second and third post. But it would be a waste of resources that each blog post will go to the server and ask for its own information. It's much better is the blog post component is only responsible for displaying a post giving its content, and not for calling the API for getting this information, because it can also be reused in different ways, no? And so maybe the component that holds the list of the posts would be responsible for fetching the information from the server. So let's say the blog list component that I was imagining has the responsibility of fetching the data for all the posts and then giving it to each of the blog posts, individual posts themselves. So there's an extra question we will need to answer, is not just a component, which is its input, so what are the properties, and what's its output, the part of the page that is generated, but the third question will be, which is the state, the information that this component needs to remember for the use of its own children, basically. So we come to programming patterns originally about the state. State is a special set of variables. They are not normal variables. Inside the function, we can have variables, but since we are inside the function, when the function is finished, the variables are destroyed, so they don't remember anything. A state variable is a special variable, special because it's managed by the framework, not by ourselves, that retains its value across different invocations of the same component instance, or the same instance. If I have 3 components, the same component instance hit it 3 times, they will have different states. And we have very strict control about how to mutate the state, because we want to avoid a situation in which a component updates something and another component still doesn't know about this value being changed, and so we want to avoid inconsistency in the page. So that's why we have some strict rules about components, about states, sorry. Okay, so this is okay, I just want to tell you a bit more about the syntax, so that you are more free to experiment. Okay, this slide is basically the terminology. There's a fine difference between a component or an element, but I think that we can skip it here. Basically, when you create an application, you start from predefined elements that are provided by the React libraries, and each element has actually these 3, and our components can be custom elements, okay? A type, properties, and children. This is what we wrote before. We have one element of type app that has no properties, there's nothing here, and has a set of children. Actually, there's one direct children, which is div, which on its turn, this div component has 3 children, each one welcome and welcome. You see the tree of nesting of the elements. So this actually is an element tree that has been returned by this component. And one of these elements in the element tree on itself is a component with some parameters here, some properties. The basic syntax is this create element call, but we will never write create element ourselves because JSX syntax is much simpler for doing the same thing. A convention is that some predefined elements React elements are those corresponding to HTML elements. So in the DOM library, we have, when I wrote here h1, for example, this is actually not the h1 element in the DOM. We are not writing HTML here. It's a React node called h1. So all the HTML nodes are reflected into the React library with the convention that they are lowercase. And so we can distinguish predefined, say, HTML elements from custom elements, the one that we create, that by convention are always uppercase. Up is uppercase, welcome was uppercase, and so on. We can mix and match them as we want once we create them. So by using them, there's no difference between predefined elements and custom elements. And the JSX syntax helps us. There are just a couple of syntax points. So all text must be closed, like I said before. And the arguments usually can be strings or objects. The argument of the properties. Okay? Strings are normally between quotes. Objects are between braces. So, for example, I had this example, formal, yes or no. The salutation is formal or is informal. I don't like it very much to write no or yes. A Boolean would be better. Okay, so but I cannot write true like this. I need to say that the argument of this property is an object, and in this case it's a Boolean object. So whenever we have an expression, a JavaScript expression, we need to use the braces to say, okay, the argument is not a string, it's an object. Or it's a string and then I need the quotes. So always quotes or object syntax. Also with numbers, okay? We can have, how many times do I want to say it? 3 times 4. So I can say welcome many times. So I can use in this case, it's not a string tree, it's a number, so I can iterate on that. If I want to update the welcome component, this is not just, I cannot just return one string, but I need to iterate and return it many times. And it can be boring. What do I need? Okay, I need to have a component that says welcome many times. I need a for loop and whatever. No, let's create a second component, single welcome. Single welcome. That will do this work once. And then the welcome component uses that many times. So let's try to break it down to smaller pieces. So if, let's say, if props dot times is defined, then otherwise I don't know, return single welcome with the same properties that I got. Let's say something like that, just to avoid. So for example, let me try, sorry, what's the code here? In up, the times is applied only to the English, for example. So if I don't have the times argument, I should just use the component that we have. If I have the times, so because I'm running this part of the code. But if times is defined, I need to return it many times. But there's only one return statement. So I cannot just call the components many times. I should create something that iterates and creates a list of components, in a way. And this can be done, and normally will be done by functional programming. So I could have many components, okay, of the same type in a list. What I need to do is just a mapping from something like list.map, sorry, dot any element of the list, I don't care, about a welcome, single welcome, with the same properties that I've got here. So for example, language is especially props.language. So I can call the single welcome as a function, but it's better to call it as a component with the same properties. Language is props.language, and formal is props.formal. And again, so what is this list? It should be a list with times elements, whatever they are. So many 0 times 3 times or 4 times and so on. So we must build that to use the map. Okay. So for example, just a stupid thing, const I equal to 0, so like I equal to 0, I am less than props.times. I have list is an empty array, and then increment I, list push 0. I don't know if it works, let's try it. So the times, so the English is times 4. Let's see. Sorry, I didn't return anything. Of course, it's an empty component. Yep. So there are tricks. A component returns an element tree or a list of element trees that are then inserted into the page. Okay, this was a very nasty one, ugly one, not nasty, because there's no way in JavaScript just to create, or maybe there is to create an array given the number of elements, but this is just a detail. Usually, we don't do this stuff. Maybe just to show that maybe you have a list of elements and we want to render all of them. Using map is a good way of transforming the data that we have into the elements, the React element that we need to display them. And this can be done by passing these arguments with the object syntax. And inside the braces, we can have, like I said, also variables or general expressions. Okay, so there will be shortcuts for passing all the expressions down there, but they are for later. Let me see. Oh, just remember, JSX syntax creates an expression. So it can be used everywhere. You can use an expression from the syntax point of view. So you can also, normally we use the JSX syntax just before a return. Return a list of elements or return a single element, okay. Or return, but we could also take it and store it somewhere, like store it into a variable and do process it later. It's just an object, like it's just a strange syntax for creating an object, okay? An object of type React element, but nevertheless an object that can be stored and used in many times. Okay. Yeah, this is just remember using the braces whenever you have an expression. There's just the details that well, just checking if there's something important with the syntax. We will see a lot of this stuff, not today, but saying, for example, I have, how do I read this? You see that we have an expression, UL, that closes there. So inside the JavaScript code, we have some React elements that contain, inside braces, some JavaScript expression. And this JavaScript expression contains, in this case, a ternary that will check a Boolean variable. And the result of this ternary will be, again, React elements. So we have JavaScript that contains JSX, that includes JavaScript again, that includes JSX again. So there's no problem. We just need to be careful, but we can nest both languages as we want. So inside a JSX context, we can open a brace and drop into JavaScript, normal JavaScript code. And inside any JavaScript code, we can open a bracket and enter into JSX code. And these braces, you see that we use them here as argument, or can be also, like here, inside the children of an element. And the children will be, in this case, the result of the JavaScript expression that we have evaluated, that needs to have some logic. This lends us to have, in many cases, one big return statement with many ifs or conditionals inside this expression. So many components will be just a very big expression that we won't have many intermediate variables. One big expression that internally can be customized. So actually our very simple single welcome, normally it would be routing like this: return p, and then in JavaScript props dot language and props dot language equal to Italian, then benvenuti, else welcome. That of course is the same, but you see this written as an expression. So we tend to prefer, it's not very readable, but we tend to prefer, for compactness, one return statement and maybe some conditions inside the code. So I don't like it very much because it's not, we must really maybe work with indentation to be clear about what we are doing. But instead of trying, if something, return this or return that, we tend to do one return statement and try to customize inside. Maybe because we have a long block of text of HTML that only one little part is changing. So having a return 1 or return 2 will be a lot of copy and pasted code, and so we tend to have only one. So all the tricks about using ternary expression or using shortcut, short circuit evaluation for Boolean values, like you said, using AND or like a sort of default values or embedded values, are used a lot inside this kind of expression. Okay, so just don't get lost. The important point is that at the end of each component, we need to have a return statement that returns one component tree or a list of component trees. Like we did before, a list can be normally computed by a map. A list can be an array, of course, or other kind of data structures. Okay, so this is the basics. For the next time, we'll try to learn about this, about how to create the structure of a page. So after the exercise you do this week on basic HTML, we'll try to do that on React next week, and try to add some state to make something a bit more dynamic, because otherwise we can pass the properties, but these properties are just written inside the code, so it's not really dynamic anymore. Okay, so I give you some time to rest before Francesca comes over for the next hour.